Maxhead is a limiter maximizer with several exciting features. So let's quickly see how it works. A limiter is a dynamics processor that prevents a signal from exceeding a certain threshold, which is set with this ceiling parameter. If I lower the headroom parameter, I decrease the distance between the signal and the ceiling. This results in an increase in the amplitude of the signal. As you see and hear, the output signal is now louder because the distance between the signal and the ceiling is equal to the distance between the input signal and the headroom. The limiter attenuates signal peaks that exceed the headroom to prevent them from exceeding the ceiling. Visible in this histogram is the red attenuation curve, which drops at the peaks. An important parameter is the release, which indicates the time it takes for the attenuation curve to return to the top after a peak. If I lower the parameter, the curve changes, becoming much faster, and consequently, the sound changes. On the other hand, if I slow down the release, the curve becomes a brick wall that keeps the sound consistently low. In addition to the release, we have the attack parameter, or clip, which is this red knob. This parameter sets the time it takes for the limiter to attenuate the signal when the signal exceeds the headroom. In theory, this value, which is a percentage of the release time, should always be set to 0, because if the attenuation is not triggered immediately, the signal will exceed the ceiling value and cause clipping. In most cases, this is undesirable because it causes distortion, but in the case of percussive sounds, such as this one, clipping can make the attack transients more impactful. As you can hear, the sound attack is now much more defined and louder. Here, we can see the various types of envelope followers, which determine the shape of the attenuation curve. So far, we have used the clean type, which is the most transparent, but there are others. Let's try the aggressive type, for example. The attenuation curve is now much faster and segmented, that is, not smoothed. And of course, that changes the effect of the limiter. With the slow type, the curve responds more slowly and produces a different effect, favoring peak limiting over loudness gain. The resulting effect with the clean type is much more transparent, as we said. Last but not least, the transient type, which is the most complex of all. Here, the speed of the curve depends on the transients. It is faster with steeper transients and slower with softer transients. It is also possible to crossfade between the different envelope follower types using the type parameter. For example, we can mix the slow type with the aggressive type to find the right kind of limiter response. Any pair of adjacent types can be mixed at will. So far, all of the processing we have heard has been done in the limiter mode, which primarily aims to ensure that sound peaks never exceed the ceiling. On the other hand, if in addition to this, we want to increase the loudness of the original signal, we can select the maximizer mode. As you can hear, using this mode but keeping the same parameters, the sound is much louder. In maximizer mode, clipping can be more effective. If we want to emphasize the effect even more, we can switch to the aggressive type and get a very loud, almost distorted sound. Here we have the saturator, which modifies the waveform, especially at low frequencies, creating a slight warm distortion typical of analog hardware limiters. parameter sets the frequency band on which the saturator acts. The default value, 0.5, favors low-mid frequencies. As the parameter is increased, the brightness of the effect increases. Below 0.5, the low frequencies tend to overpower the other frequencies, and the sound becomes increasingly darker. The look-ahead parameter delays the input signal before it is processed, giving the limiter time to reduce the gain before a peak arrives. It can be kept very low to make the limiter react faster on percussive sounds, while for instrumental or vocal sounds, it is advisable to keep it at the default position, 3 milliseconds, or higher. The dry-wet parameter mixes the input signal with the processed signal. Finally, the bypass button allows you to listen directly to the input sound for quick comparison with the processed sound. And that's it! Thank you for following our Maxhead tutorial. See you soon.